Hello everyone. Today I am continuing the limit expression evaluation once again. How to evaluate this expression that is being written over here. Limit x tends to 0, e to the power x minus e to the power minus x divided by sin x. What will be the value of this? For doing this, I am just writing the next step as limit x tends to 0. I am adding and subtracting 1 in the numerator. That means e to the power x minus 1 plus 1 minus e to the power minus x whole divided by sin x. Whatever be the limit expression, we have to use some of the basic fundamental things. That is some of the basic fundamental rules of limit, but none of these things are being visible over here, because you can understand if x tends to 0, then sin x will be, if I just directly put x equal to 0, then sin 0 is 0. That means in the denominator it will be 0. That is, it will be an infinite expression. So that cannot be a positive solution for this problem. So for doing this, what I am doing, limit x tends to 0. In the numerator portion, the entire numerator I am dividing it with x. That is 1 minus e to the power minus x plus e to the power minus x into e to the power x minus 1. That is the entire numerator. I am dividing it by x. To compensate, I have also divide the denominator by x. That is, I have to write sin x divided by x. Right? Now, there are multiple limit expressions in numerator, denominator, and in addition format as well. We know that if there are multiple limit expressions, we can separate them in numerator portion and denominator portion separately. How? So, if I write this expression, then it becomes, in the numerator, limit x tends to 0, e to the power x minus 1 by x, that I can write. Okay, so I can write it as limit x tends to 0, e to the power x minus 1 divided by x plus limit x tends to 0, 1 minus e to the power minus x divided by x, right, whole divided by denominator. I am not writing the denominator right now. That is also a limit expression. What is that? That is sin x by x, right? So I know what is the denominator. Denominator is limit x tends to 0, sin x by x, which is the basic fundamental formula as 1. So I am not bothered about the denominator here. So my basic purpose is to evaluate this limit and this limit in the numerator, and if it is divided by 1, the same expression remains as the value. So here I can write it as limit x tends to 0, e to the power x minus 1 divided by x. It is also a basic formula that is evaluated to 1. And limit x tends to 0, I can write it as 1 minus 1 by e to the power x, because e to the power minus x is nothing by 1 by e to the power x by x, right? So this expression is 1. So this is limit x tends to 0, 1 plus limit x tends to 0, e to the power x minus 1 by x e to the power x, right? So I can write it as 1 plus limit x tends to 0, e to the power x minus 1 by x, right, into limit x tends to 0, 1 by e to the power x. Product of two functions in the limiting expression, I am separating into two different limits. Now this is 1, from the basic fundamental formula of exponential limits. And anything to the power 0 equal to 1, we know e to the power 0 is also 1. So limit x tends to 0, 1 by e to the power x is also 1. So the entire expression when multiplied is 1. That is 1 plus 1 equal to 2. So what we have learned from this, if any kind of expression including the exponential and the trigonometrical expressions are there, if we directly put the value of x as 0 or whatever, that is x tends to what value, it might mislead us to different infinite value or misleading answer. So we have to convert them in a proper basic fundamental rule theorem as I have done it by adding or subtracting or dividing by x or any other variable to meet our purpose. So this is the solution for this particular limit. If you like this video, I will request everyone to view, watch and subscribe my channel. Thank you.